Let's find the solution to the following second order recurrence relation. And again, we start off by writing this in standard linear form. So we have Sn minus 4 Sn minus 1 plus 4 Sn minus 2 is equal to 0. And again, we assume a solution of the form Sn is lambda to the n, and substituting this in our recurrence relation, we have lambda to the n minus 4 lambda to the n minus 1 plus 4 lambda to the n minus 2. And that's equal to 0. And then we factor out lambda to the n minus 2. So we have lambda squared minus 4 lambda plus 4 is equal to 0. And therefore, for an arbitrary lambda, the characteristic equation must be equal to 0 for this equation to be satisfied. And we can factorize this as lambda minus 2 squared, and that's equal to 0. So therefore lambda is equal to 2, and we have a repeated real root. So for this case, the general solution is a constant a plus a constant b multiplied by n by lambda, which is 2, to the power of n. And now we can apply our initial conditions. So S0 is equal to 3 gives a plus b by 0 by 2 to the 0. So that's 0, 2 to the 0 is 1, so this gives the constant a is equal to 3. And our second initial condition, S1 equals 2, gives a plus b by 1 multiplied by 2 to the power of 1. So dividing through by 2, we get 1 is a plus b. And then if we substitute a equals 3, we get b is equal to negative 2. And therefore our particular solution is 3 minus 2n multiplied by 2 to the power of n. And you can check that this is valid by substituting it into our original recurrence relation to verify that this equation is satisfied. Please subscribe, like and comment to help me reach more students.